this problem, we're asked to consider a rational function and find the degree of denominator. Part A is asking us to find the degrees of numerator and denominator, then find the x-intercept, y-intercepts, and all these properties of this rational function, and hopefully we do some graphing without calculus, basically. So the first thing that I want to do is to find the degree of numerator and denominator. And over here, I notice that the highest exponent in here is 2, and highest exponent in the bottom is also 2. So it's 2 and 2. Having the same exponents, top and bottom, numerator and denominator, gives me the idea that there will be a horizontal asymptote. Now, let's try to find the x-intercept. To find the x-intercept and y-intercept and go further in, I kind of want to have the most simplified form, right? It's just at this point, let's do the most simplified form. So r of x equal to x squared minus 5x plus 6 over x squared minus 25. Factor them out. Here, two numbers multiply to be 6, and they add up to be negative 5, and that's x minus 2 times x minus 3. And here, it's difference of squares, so x minus 5 times x plus 5. Here I can see that basically the zeros of the numerators and denominator are different, so this is the most simplified form. Now, zeros of the numerator are going to give me zeros of the function. Those are going to be the x-intercept. And so what I have is x equal to 2 and x equal to 3 are the value of the x-intercept. That's x-intercept points are 2 and 0 and 3 and 0. Now, for y-intercepts, I have to plug in 0 for x. So every time when you're trying to find x-intercept, you are looking for making the output 0, and that's by setting the output equal to the numerator equal to 0. When you're trying to find a y-intercept, you set the input equal to 0. So r at 0 gives me the y-intercept, which is 0 minus 2 times 0 minus 3 over 0 minus 5 times 0 plus 5. The top is going to be 6 over negative 25. So this is negative 6 over 25, and that is equal to negative 0.24. Okay. So r of 0 is negative 0.24. Identify all horizontal and vertical asymptotes. So for vertical asymptotes, I need to look at the most simplified form. That's why we simplified them. I mean, this case, we didn't have to, but we want the most simplified form, is that to find the factors of the denominator and set them equal to 0, anything that makes the denominator equal to 0. So in here, I get x equal to 5 and x equal to negative 5, setting them equal to 0, x equal to 5, and x equal to negative 5. These are the vertical asymptotes. And then for horizontal asymptotes, because this equation, this function is a rational function, and the degree of numerator and denominator are the same, it's just going to be y equal to the coefficient of these two. If you remember, it all depends on the degree of numerator and denominator, and coefficients are 1 over 1, so y equal to 1 is the horizontal asymptotes. Then the next part is asking us to plug in a bunch of points, and here if you use your calculator and you plug in the values like this, this one is minus 5 times negative 10 plus 6 over minus 10 to the power 2 minus 25. Let's correct that. And you get 100 plus 50 plus 6 over 100 minus 25. And then that value is going to be approximately 2.079. So 2.079. Do the same thing for 2.5 and you get 0.013. And then for 10, you get approximately 0.76. And then the last thing that it's asking before extra credit comes in is to find the domain of R of x. So in the rational functions are not defined in the holes that they have, or in the zeros of the denominator. Rational functions are not defined on the zeros of the denominator. And so again, here when I'm looking at that, zeros of the denominator are 5 and negative 5, so exclude those and you get negative infinity to negative 5, union negative 5 to 5, union 5 to infinity by excluding negative 5 and 5. Negative 5 and 5. This piece is negative infinity. You always start from the lowest number to the high, or lowest symbol to the highest symbol. And then here is negative 5 and 5, and then 5 and infinity, and you union them together. So extra credit 1 is asking us to sketch a graph of R of x, labeling x-intercept and y-intercept and asymptotes, and at least 3 extra points. I know that in pre-calculus we cannot compute the local min or local max of these graphs of rational functions, but I still can use sort of an end behaviors and a little bit more extra work in there. So that's all we're doing. So if there are some extra max and min in there, we can't quite tell where they are at. And so let's just put in whatever we know. Over here, I know that there are 2 x-intercept, x equal to 2 and x equal to 3. So right there. And then I know that there's a y-intercept at y equal to negative 0.24, which is right about there. There are 2 vertical asymptote, x equal to 5 and x equal to negative 5. And so 5 is approximately this. Negative 5 is 1. And then we have a y equal to 1 as the horizontal asymptote. So vertical and horizontal. Now, the next thing is this. I know that there are 2 zeros in here, x equal to 2 and x equal to 3 are order odd. So graph goes through the x-axis while we're actually passing them. So a graph goes through x-axis, and I know it's ending up there. So let's use red. It goes like that. And then over here also, there should be a maximum in there. I cannot tell what it is, but I know it's not getting any bit. The values over there are pretty small. I don't know how big it gets, but I know it's not going to be very big from experience, sort of. And then I go like that. And this should have been a little bit that way. And now the other thing that I have are these 3 points. One is 0.0113 for 2.5, which is somewhere between 2 and 3, right about there. And that seems right. And then I have another point for f at -10. So -10 is going to be right here. The f value is 2 point something, so it's about here. And then at 10, I know it's going to be slightly less than 1, right about here. I know that x equal to 5, even though it's not in the domain, when to the right and to the left, the sign has to change because the order is odd. So the sign it's the vertical asymptote should start over here. And for x equal to 5 also, vertical asymptote should start here. And I'm going to draw like this for the horizontal asymptote. Here it's kind of gets funny. It comes down below the horizontal asymptote, and then it goes through that point, and it becomes a little smooth. So there is something going on in here that I cannot tell with pre-calculus, but it gives me an overall feeling of things. Now, the last question, there could be actually a question before that, is asking me where is this inequality going to hold? And that I'm going to use basically a number line, put -5 whole, 5 whole, and then 0.2 and 0.3. So I can basically take it as since I have a y equal to 1 as horizontal asymptote, I know that in either sides, the value of the function goes toward the positive value. And then I can use test points after that and plug in, let's say, between -5 and 2, there's a test point. There's a test point, let's say 0, and the value of the function at 0, I sort of know what that is because I just computed that when I was doing the y-intercept, and the y-intercept was a negative value. So we can do that, or I could have said that -5, even though it's a 0 of the denominator, is of order odd, therefore this sign has to change from positive to negative. Here at 2, sign has to change. Here at 3, these are the zeros of the numerator, sign has to change. And then at 5, sign has to change. So the places that the sign is going to be negative are between -5 and 2, and 3 and 5. So -5 and 2, and 3 and 5. And we're not including 0 because this is strictly less than 0.